the topic that me and Johan will talk about today is how to think about DevOps-friendly API architectures. My name is Erik Andersson, and I'm an API practice lead. I usually help companies build better APIs and organize the work around these sophisticated API platforms. Johan?
Yeah, my name is Johan Kitti, and I work as an API technical lead. I've been working with APIs and cloud solutions for many years, supporting our customers to help them onboarding on these different platforms. And today my focus is API and DevOps. So you can go on, Erik.
Yep. Thank you. All right, so today we're going to look into three different learning objectives. The first one is to try to understand why it can be challenging for a very DevOps-centric organization to make use of a centrally deployed API platform. And then Johan will look into how it's possible to automate phases of the API lifecycle management. And then finally, we dig into looking into three different patterns or two different patterns which will show, depending on where you do things, will fit certain organizations better than others, and some constraints around it. All right, so let's start very wide, not anything at all. This slide is about trying to position our topic today in the global, or the APIs in the big picture. When it comes to working with APIs, consistency is very, very important. And this is very easily described as having APIs with the same look and feel. And to do this, you can have templates, guidance, linters, and many sort of supporting tools and templates to accomplish this. And this is really important because consistent APIs, they're easy to use. The second big one, I would say, is about controlled evolution, because if you design an API, you build it and expose it, and then all of a sudden you get API consumers, then it's really important to treat that relation with these API consumers with care. Yet, as any successful software product, things need to change. So, and it's the same for the API. So I say the second biggest challenge is actually to manage change in your APIs. And there's various ways of doing that, but that's not the topic of today. And the third one, it's about speed of change. So this is, regardless if you know how to design very consistent looking APIs and you actually know how to change them, you have to do this with speed, else you lose your competitive advantage. So the topic we have today about talking about DevOps-friendly API architectures, that's tied to how you can work with APIs and do it faster. So it's DevOps-friendly API architecture. So we must start by having a look at DevOps. So DevOps is not new. It's been around for 10 years. And it's a cross-functional collaboration between developers and operations. And the reason it came to be was that it became apparent that it was a need to frequently and reliably change a system in an operational state. And to do that, you have to look how the organization was set up. We had developers and we had operations, and they witnessed a tension between these groups. So the solution was to form them into one coherent team to make the collaboration much more efficient. So in a sense, this DevOps team, it's self-sustaining because it does not have dependencies to other parts of the organization. So they're independent. They need to have the skill set to manage, developing the application, deploying it, and operating it, and all these things. And it's also important that they have the mandate to actually take decisions within the responsibilities of their application. So to sum things up, then it's about taking ownership and responsibility for actually developing software and pushing it all the way to production. And to achieve this, there's a great emphasis on automation, and you have to try to stay away from manual control gates, such as approval steps. All right, so to the left here, we have a very DevOps-centric organization from a helicopter perspective. So a bubble would typically be a DevOps team, independent, sustainable, without dependencies. All right, so why can it be hard for DevOps teams to make use of a centrally deployed API gateway? It's because when we have this setup, the DevOps team actually lose their sort of independence because all of a sudden they rely on a different team. So if we're going to develop an API, for example, we start by defining the information requirements, and then we model that in an API description, open API document. And then we develop the server side of the API contract, and all these things can be done in isolation, no problem. And then the DevOps team deploy their application, and now it's time to publish it in the and to do that, they have to reach out to a different team, the team managing the centrally deployed API management gateway. So in this case, we run into trouble because now we have a dependency between the DevOps team and this different team. So this team overlapping activity results in a coordination cost, and that will make the DevOps team lose speed, and that's not good. So let's have a look at this relation and see how it looks in a big organization. So at the bottom, we have API providers. It's down here. We have the API platform team. That's a central team. And then we have API consumers at the top. So far, so good. The API platform team can manage this, no problem. Then there's a bunch of more API providers, and then we end up like this. So we basically have a lot of API providers that needs to go through this bottleneck API platform team, and we have a lot of API consumers, even more API consumers, I hope. And when it comes to the relationship between the API platform team and the API consumers, you can manage that relation using a developer portal. But of course, you have to design your API and describe it in a very thoughtful way, so it doesn't render in questions which the API consumers can't figure out on their own. But the topic in this session is about the relationship between API providers and the central API platform team. Johan?
Yes, before Erik goes into these two steps, he has blown the option A and option B. We need to talk a little bit about configuration as code. And this is kind of a need to be able to do those things that Erik will talk about later. So if you change the picture Erik, you can go to the next picture, so we jump over this one. So what I'm saying is that you need to go to configuration as code, or it could be configuration as code combined with the infrastructure as code, because sometimes those is going together, and put these things in the Git repository. And the reason for this is that you want to gain speed and the quality, and you will not have that, I'm saying, if you don't do that. And we have seen this with a number of customers that we have been helping out. And if you don't do this, it can end up in a really complete mess, I would say. And the stakeholder might not be so happy. But I will try to give some example why I think you need to go in this direction. I would say many of the API management products or API gateway, or you could go for a cloud solution or an old integration platform. Many of those one have a rich, great UI where you can start doing things. And it's quite easy to try out things there. But this is nothing that scale and you don't get speed. Because what you usually do then maybe is that you configure something manually in one environment and you realize I need at least to have a dev test and production environment, for example, because you don't do things directly in production the first time. And then you do it and you realize, okay, I need to repeat what I did in my dev environment in the test environment. So if you take the manual approach, you write the documentation and you provide that one and say that you please follow this documentation and set it up in test environment. And then you do the same for production. But this is really human prone. I mean, it's so easy to write wrong things there and copy paste wrong things. And you usually also have environment specific things that you need to have, and you need to put that one in the documentation. And then you realize, okay, I need to make a change. Then you go and make a change in the manual documentation, and then you need to do that in test and production. And then you realize, oh, I have an urgent problem in production. So you make the manual configuration in production, and suddenly you have lost track of everything. You don't know if this document is up to date. You have lost speed. You don't know who did what. And then you decide, oh, I need to roll back. Or roll back to which document should I use? So by doing this, it makes things hard. And the thing is, but let's say that many of these platform has like you can configure something via the UI in the dev environment, and then you can push it to the test and production environment. And you have some way of doing it. There is some auditing, but you don't get you don't get anyone to review your changes because that's not usually built into this process. And what happens if you haven't taken a backup of your environment? Because now we are talking about that we have an up and running an API management platform where you configure like maybe 50 or 100 different APIs. And that one crash. And you need to go through and do this all things manual because you hadn't taken a backup or the backup was old, you don't know what you had. Or even worse, you have these things and you want to spin up something in another region. You take this manual approach and you spin it up in that region. Suddenly you need to change something. Then you need to go through all those environments to make these changes. But if you would have this one as configuration as code in a Git repository, it's easier to have the audit. It's easier to much faster to push it to different environments. You can put the environment specifics together with the code. You can have someone that checks what you have done, so you follow the things. This is much faster. And one thing also is that if you are going to start doing repeatable things, if you have something as configuration in a Git repository, that will be much easier to kind of templating or making some pattern that you could reuse. It's hard reusing manual things. And this is one of the reason that you should do this. And sometimes that might be like it might be that those platform is not fully supporting this doing configuration as code, but usually then someone else has written a CLI tool that you can use, or there is a REST API that you can wrap. But almost for all platform, I would say that there is an API you can use to configure your APIs in the platform. You can also export the things from the platform. And for example, what we did have done at some of our customers is that we could keep both in a sense. So what we could do was that we could let people configure an API with all this policy and all those things in the UI if they want. And then they export that setting and we put it in the Git repository and we push it out again. And then you have what was in the Git repository again in the API management platform, and you know that the Git repository is the master. And we did this to give the possibility to change the code in the UI or in the configuration that it was in the Git. But that is not the only thing you get by putting it in this Git repository. As I mentioned before, you could do templating. It's easier to take something and do repeatable stuff. You can set up things so you can generate almost the same thing over and over again. Because usually when you set up an API in an API management platform or in a gateway, you usually want to apply the same policies, same OAuth thingy, and a lot of other things. And in that sense, it's easy to have something that do the same thing over and over again, and just maybe make some change to naming and those kind of things. And then when you have done this and you are in a Git repository, then you open the world for the DevOps teams, what you can do, because the code can be moved to different DevOps providers. A different team can call your pipelines if you want, or the team can own everything. You can add review steps in the beginning, and those review steps doesn't need to be human-based if you don't want, because maybe you store an open API specification, you have some configurations, you might have some JavaScript, you have documentation in Markdown, then you can run linter on top of this one. So when people push this to the Git repository, you have those linter tools checking these things. And it's easy to sync with different projects. And I think by doing this, you gain speed, you get better quality, and I think the manual thing no one's tried to do nowadays. You need to go from it. And you will see that now when Erik talking about things, that this is some of the part that you need to gain this speed that he was talking about. So over to you, Erik.
Thank you. All right, so now we're going to look at one of the patterns, and this is about granting the DevOps team access to the API gateway, and the target here is speed. So to do this, we have to transform the central API platform into a multi-tenant SaaS solution. And to be able to do that, the central API platform must have a quite flexible access control model. From experience, at least some of the older ones, they are still quite aligned to the, a certain group will do the development, a different one would do the operations. But in this case, we need to have a very flexible models where we can simply carve out a piece of this central platform for each of the DevOps team that needs access to it. And before, even though we can do that, it's developing in this type of central platform can be quite challenging. It's not you can program in many common languages, but it may be new concepts, and also for a developer it may be very challenging for programming for a distributed computing, and one example is for what I have attached to the right here, policies of distributed computing. The network is reliable, latency is zero, and these things are of course not true. And then you can make use of quality assured building blocks. This would be maintained by a specialized team. So having these building blocks, it would be easier, much quicker for someone new to the platform to build good enough integrations. And then, as Johan mentioned, we also need to have a great degree of automation to make this work. So here is a model. Here we have a responsibility border, same one down here, just different. Here we have some deployment unit. Here we have the API. So let's see what this pattern looks like. Here we have the API platform. We have platform building blocks. We have configuration as code, and we have this dedicated team managing these. And then we have the DevOps team with their responsibility. They have two microservices maybe. But the idea here is now the responsibility spans, going into the API platform. And this is good for organizations where you have a lot of DevOps teams. And perhaps you have bought a very expensive API platform and you want to get the most out of it. And it's in one sense it's good because if the entire organization sort of goes all into a platform, then the training needs becomes very clear and you can get benefits of scale when you plan for that. But of course, there's doing this. There's also a heavy investment in a specific platform, which will result in vendor lock-in. And it may not be technically possible because of the underlying access control model. And then finally, it's DevOps teams. It's a lot about having their sort of mandate to take decisions on how they solve problems and what tooling and stuff to use. In this case, they're forced into a platform. Okay, the next one is speed by simplification. Here we split up generic and specific API gateway features. Generic are the ones which requires little knowledge about the underlying API, and the API provider specific is the opposite simply. So we're going to simplify what's done in the integration platform. And we do that by having taking away stuff, basically. And of course, we have configuration by code, and we gain speed and robustness by these reusable quality assured building blocks. So we do less. We remove message translations, content filtering, and enrichment. We do simpler things. We don't manage like an aggregate where we aggregate many different API endpoints into a single API. Instead, we manage a simple one-to-one pattern. And then we introduce the API Microservice Gateway and push that very close to the DevOps team. So this becomes their first facade where they expose their API. So adding this pattern, it will look something like this. And we get the benefit here is that it's good for teams with organizations with many DevOps teams. It's good because it's easy to implement, to put no special requirements on the central platform. It's good because it's clear responsibility borders. And of course, one major drawback would be that there's still a coordination costs because it's two teams that need to communicate with each other. But we try to minimize it. And then I've added a third one. This is quite common. This is fine. Perhaps you have an application which won't need to change very often. And perhaps you don't have the team around it to actually manage it like a DevOps application. In this case, why not use the central API platform for managing integration logic? But be aware that you're when things scale, this central team may not hold for the pressure. So to summarize things. We talked about the natural tension between the DevOps teams. They're decentralized, and then we have the central API platform. There's a natural tension there. Johan also talked about how we can use configuration as code to automate things during the life of an API. And then we've gone through 3 different patterns for how you can decide where you implement specific integration logic, depending on the capabilities of your API platform, how you have organized within your organization, and also how the API provider, at what rate that application needs to change. So, questions and answers.
Yes, thanks, Johan and Erik, for the presentation. We have at the moment 2 questions from Tom. The first question of Tom is, would you only put an abstract config in the source repository or your entire pipeline?
I could say like this. What we did first of all was what we have done is that each API has its own lifecycle first of all. So each of those API has its own repository in a sense, because you don't want to mix many API in an API management platform. And what we also this because I combined those 2 questions there. To configure an API in an API management platform gateway, you normally need to have some knowledge, even if it's configuration of code or manually. But the goal here is to, one step we did first, what we just gave to the developers, we generate a repository with all codes, and it was deployed, and it was one that was working. And then they could continue from there and modify this specific API configuration if they needed. But sometimes you don't need to do that, because you have kind of a formula where you can fill in stuff, and then you generate this, push all of these things into the environment. And in that sense, they should just be able to push it forward to different environment without needing to do anything if they follow the standard pattern. If you add something extra, you might need to do something, and that's where you might need to take help of someone that knows this kind of platform. But usually the goal is, as Erik said, is trying to push to do standardized things, so they don't need to do anything in this API management platform. They just need to push kind of a button from their part, and their resources is put into this platform. And you try to see that they don't need to know how to do things. Yeah. I hope this answered the question.
For me, yes. And for Tom, I would say if you would have an additional deeper question, let me know by the chat. Then I will also mention the second question of Tom. That's basically, it's based on his experience that all projects start to implement their own configuration as code, and that as a result of it, the learning curve for new people is quite high. What's your experience with that, Johan and Erik?
That has been what we try to. Because we first started in the general, they were just a small API team first to start up. But the goal is to lower these things, so they shouldn't need to know how to do things if they follow a standard pattern, because those things will just be generated by code in that sense. So you can set it up this way by using different pipelines and for each API. And it will kind of follow when they go to dev, you can use Git flow to use this one to put to dev, test, and production, so they can control when they go to different environment. But it's important also, the ones that is managing those platforms also want to have some kind of control also. So, but package all this together, you can help out those teams, and you can go step by step to in the end up in this nirvana that Erik is talking about. Erik could probably say something more if he had something to comment.
I'm fine, thanks.